Greetings to the lecturer and my fellow teammates. My name is EZEKIEL Analaki ELLAPEN and my metric number is B0921103004. Today, my teammate and I would like to present about a lab with the title of Design and Analysis of Car Disc Brake System. Firstly, as for the objectives, the main purpose for this lab is to design the disc brake in virtual reality. Secondly, to define material properties of disc brake rotor. Thirdly, to analyze disc brake rotor based on the brake force. For the equipments we used in the lab is only CATIA V5 software, which we use to draw the rotor disc and to complete our FEA analysis. And now I would like to present about the basic functions and how does and what a rotor is made of. The disc brake has metal disc or rotor instead of a drum. It uses a pair of flat line shoes or pads that are forced against the rotating disc of produce braking. The pads are held in caliper that straddles the disc. The caliper has one or more pistons with a seal and dust boot for each. During braking, hydraulic pressure behind each piston pushes it outward. This forces the pad into contact with disc. The resulting frictional contact slows and stops the disc and wheel. If pads on one side are worn more severely than the opposite side of vehicle, the piston may be stuck in cylinder of the opposite caliper. Brake discs should always be renewed or refinished in pairs, both front or rear. Even if only one is damaged or defective, never renew the pads on only one wheel. Also, the dust created by the brake system may contain asbestos, which is harmful to your health. Never blow it out with compressed air. An approved filtering mask should be worn when working on the brakes. And now I would like to present about the calculation of factor of safety. A factor of safety is related to the safety of people. It reduces the risk of failure of a component by adding some cushion in design. Also, there always will be some hidden circumstances or unknown parameters that can be considered accurate in design. At the same time, the reliability of material is not 100%, and the load used in design calculation is not the maximum load. So the factor of safety or safety factor provides protection against those unknown events to some extent. Although all components are designed with a factor of safety, it always suggested to use those components within their design limit. Next, I would like to hand over to my teammate for the presentation of.
So hello everyone, my name is Chanding Hao, matrix number B0921101146. I'm going to present about the procedure. So this is a design, this brake auto is a design this rotor using the CATIA V5 software. So we apply the distributed force in at a brake pad area about 2,680 kilonewton. And then we run the structure analysis in CATIA V5. We will get the translational stress and the one research stress. So that's all from me. Mike.
Hello, my name is SHARUL IMAN bin JUMIZA. My metric number 0921000829. Okay, first I will conclude the data finding. This is the material property for the display for the steel. So from the material, we got ion modulus 2E plus 0.11 Newton meter square. The poison 0.266. Density 0.008 gram per meter cube. Thermal expansion from the material used that is steel, we got 1.17 E005 kilo kilo degree. Yield and for the yield, we get 2.5 E plus 008 Newton meter square. From the experiment, this is the picture that we get. For the maximum transversal displacement, we get 282, and for the minimum, we get 0. Here is the yield for the bond mistress for the display that we get 2.83 E plus 0.11 and 5.84 E plus 0.08. This is the bond mistress. For the data below, I will give to my friend Zong.
Hello everyone, my name is ZHAO. My metric number is B09211048. And today I would like to present about the calculation of the factor of safety. The formula of factor of safety is the ultimate strength divided by the allowable stress, which is also equal to the yield strength divided by the maximum one missile stress. Just now we have got the yield strength value for the steel is 2.5 E plus 0.08 Newton per meter square, and the maximum one missile stress value is 2.83 E plus 0.1 Newton per meter square, which is equal to 0.044. So that the factor of safety that we obtain is 0.044, which is less than 1. Therefore, it could be concluded that it is safe to use the steel as the rotor display material. Next, I would like to present about the discussion about one missile stress as factor of safety of the rotor brake disc. From the experiment, the minimum one missile stress is 5.84 E plus 0.08 Newton per meter square, whereas the maximum one missile stress is 2.83 E plus 0.01 Newton per meter square. The factor of safety is obtained by dividing the yield strength and the maximum one missile stresses. The obtained factor of safety value is 0.044. Lastly, I would like to present about the conclusion of this lab section. After carrying out the lab session, we can say that the risk rotor design and the material selection must be carefully considered in light of the intended application. Prior to choosing the material and design, the maximum force that will be accepted to the this rotor must be determined. Besides that, we also found that heat dissipation is a critical factor in this web performance and lifespan. The vented through holes and slit on the physical surface of the this rotor has been implemented to enhance the effectiveness of heat dissipation. Besides that, we have also learned to use the cardiac effect application to do the analysis on the rotor disc brake. That's all from our group. Thank you.